Hey, everybody, and welcome to this week's podcast. I've got Joyce here with me. Say hi, Joyce.
Hi. How's it going?
And all good, all good. Today, we've got a great guest. We can't see him, unfortunately. There's some video problems, but we have Dr. John Higgins in the house. How are you, Dr. John?
I'm very well, thanks, David, and all going well this side of the world.
Great. Where are you, John?
I'm here in South Africa, Pretoria.
Great. And how's the coronavirus? I know there's a new strain there. How are things going there?
Well, the latest strain is not concerning, actually, because the effects are very mild as compared to the previous viruses. This one seems to be mild. People get sick, but they recover very quickly. But
I've heard that as well. Yeah, I've heard it spreads very rapidly, but it's not very serious.
Yeah, it's not affecting the hospitalities and so forth.
Yeah.
It seems to last for a week, and then people are recovering. So it's quite mild in that way.
Great. Well, John, so just to give a quick introduction to our audience and everyone listening about who you are, for those of you listening, Dr. John is a doctor of electrical engineering, and he's been a mentor and advisor to me for the last 20 to 25 years on a number of projects. And if there's anybody in this world who is the most experienced quality control person I know, it's definitely Dr. John Higgins, and our black belt expert in Six Sigma and lean systems. John, maybe tell people a little bit about your background and what you do.
Right. So I started off as an electronics engineer, covering radio, microwave, TV, cable transmission, and then studied further into electronical quality engineering, and then advanced it into management to PhD level. And I was an executive for a major manufacturing company for a number of years, covering products such as TV, hi-fi, microwaves, stoves, fridges, freezers, and so forth, and audio products, and gained a lot of practical experience in quality engineering and management. And as you know, I've applied it in your company and many other companies around the world, in Saudi Arabia, and all around South Africa.
Yeah, no, absolutely, you have, and very glad to have you on the podcast, because I speak to you a lot about quality control and the principles and the background, as you know, and I've been thinking for a long time it would be great to actually let people hear firsthand from somebody like you some of the conversations we have around quality and methodologies around managing quality.
Good.
So, John, just a quick question. I know that you're involved now in doing Six Sigma training, and some people may have heard of Six Sigma, some may not have. In a nutshell, what exactly is Six Sigma? Just so we can, if it's kind of encapsulate that in under a minute.
Okay, so there are two dimensions. One is lean, and the other one is Six Sigma. Lean looks at improving the workplace from a 5S point of view, and various other techniques, where Six Sigma is more statistical. So that if you want to solve a problem and it requires statistical analysis, Six Sigma would be the way to go. Whereas Lean is much more simpler, more easy to implement, but they work together, and that's the important point. Yeah, I've been giving lectures on both Lean and Six Sigma, right up to black belt level, all around the world, and the methodology is interesting. There are 5 dimensions to the methodology, so people learn how to solve problems by using the methodology of DMAC. Okay, and students are required to do not only theoretical tests, but they have to do practical projects to show that they understand and can apply it practically. And then they qualify.
So, John, for the sake of our audience, I want to kind of explain to them a little bit. I want to bring it down to a practical level. So, go with me here. What are the 5 S's? Can you run through them quickly?
Yeah, they are sort, set in order, shine, sustain, and I've forgotten the fifth one. But anyway, those are the S's.
Okay, so the way it kind of practically looks, in my understanding, and correct me where I'm wrong, is if you went into a manufacturing environment, for example, and this doesn't only apply to manufacturing, it applies to even an office workspace or anywhere, actually, any business organization that runs, you would look at the 5 S's, and it's kind of like a management process of how well things are organized, managed, controlled, and executed. Is that kind of a fair way to look at it in simple terms?
Yes, so that's exactly correct. And if you get that correct, you're able to sustain a flow in your processes and address the defects and so forth, so that you give a good customer service as quickly as possible.
Right. So it's that basically, if your business is run on well done processes, you're going to be able to identify problems quickly and recover from them fast, whether it's a manufacturing process or even a customer service process, for example.
Correct. I always say to my customers, everything's a factory, whether it's a bank or a factory or whatever. Everything's a bank because everything's a process. A process
Yes.
is the factory.
Yeah, I agree. And I must say, when you taught me that, kind of the penny dropped for me, is that business processes are like a factory. Customer service is like a factory. If you get that process right, it's the same principles that apply everywhere. And I think that's what's fascinated me for years around 5S and 6 Sigma and these lean process management systems, that they just apply in everything and anything you do, even in software development.
Correct. I'm currently helping a customer with his warehouse. And I said to him, well, your warehouse is a factory. And he looked at me and said, I don't understand. I said, well, it's very simple. Your marketing division presents the warehouse with a pick list to deliver. That pick list is actually the production schedule.
Yes.
And that drives the deliveries. And so that sort of dropped a penny in his mind. So now they're very process thinking, and that's what you've got to get right with your customers if you're trying to help them improve their methodologies in whatever environment it might find.
Yeah, and I must say that the other thing you taught me is always listen to the voice of the customer, the VOC. And what I understand is everything you do in your business or in manufacturing, it's all driven by the voice of the customer. So if you kind of take that approach of what does the customer actually want, and then figure out how to develop and design a process for a product to deliver that, not the other way around, not design a product or a business process and force customers to go, well, this is the way we work.
Correct. So the voice of the customer is a very broad concept. So it's important to break it down into what we call critical customer requirements. So you take the high level, the voice of the customer, and you break it down into those critical customer requirements. And those are the things that the factories must attend to very serious. And then the inspection.
And when you say factories, John, just to interrupt you, from a conceptual point of view, when you say the factories must, actually, it's deeper than that, right? It's whatever the voice of the customer is, the factory or the business or the organization, whatever it is, should adapt and develop process around delivering that, right?
Correct. Absolutely correct. And it's very important those processes address the critical customer requirements. They should measure them and do statistical tests on those measurements to establish confidence that will express itself in a reliable product. And that is the essence of it.
Yeah. No, it's fascinating. When you think about it like that, it actually makes decision-making very simple and clear, doesn't it?
That's very important. People tend to complicate things. And I always break it down and make it as simple as possible so that people grasp it and then run with it. Otherwise, they get lost and they don't achieve what they should.
Yeah. I find I just see it repeatedly in my company, in other people's companies, and it's not that it's wrong. It's just that a cycle of development and improvement processes is you get so caught up in doing things because you're used to doing them that way. Whereas if you take a step back and go, what does my customer really want at the end of the day? Or what should the product actually do at the end of the day? And when you start thinking like that, then you decide what you need to do. And you can actually strip a lot of steps out of a process or a product in many, many cases.
Yes, so a lot of inspection companies develop protocols that are intense, and what they should really do is focus on those critical customer requirements, very importantly, and not get lost into the detail that doesn't have a meaningful effect to the customer.
Right. John, no, I get it. And you and I have had this discussion a lot, and I'd love to kind of go into it now a bit, because we've looked at how people inspect products at factories, and we say, like, the amount of testing and checking that's done, how necessary is most of it? Because the current process, the current way of inspecting is based on AQL levels. So I'd like to go into AQL levels a little bit, and then I'd like to go into, what is the alternative to an AQL level, and why might that be better, if at all. So maybe if you just touch on kind of what exactly is an AQL level, and how did it even come about to be, and why are we using it today?
Well, it started off in World War II when they were manufacturing bullets for the US military. And as you can appreciate, you can't test all the bullets, otherwise you have none to use. So
True. It makes sense, actually. Yeah.
It's a destructive test, so you have to work on a sample, and that's what the famous quality experts of the time, Dodge and Rommich, they came up with the Akl tables, which allowed one to select samples from the production lot and applied the sample with a confidence level, so that they didn't have to test all the products. Otherwise, as I explained, in the terms of the bullets, there would be none to use. And
right.
That's how the AQLs were developed. And they developed tables based on attributes and also based on variables. So there's two dimensions to the AQL tables. It's attributes and variables. People are very familiar with the attribute one, but not so familiar with the variable aspect.
Okay. Well, what do you mean by an attribute and a variable, John? If you can just explain to us.
Attribute is like, is the product okay? Does it appear to perform well? And,
okay.
So it's a descriptive test, and
right.
The variable test is where you measure something like the length of a lead, or the dimension of the diameter of a hole, or the weight of something, or the voltage, or the wattage requirement.
Right. So it's something that could vary, and it's a variable that could vary and may not be 100% consistent or replicable in every single item.
Yeah. So there's two dimensions to AQL, and then they said there's two ends to AQL. There's the upper end, which is the AQL, and the lower end, which is called, it's a terrible name, LTPD, lot tolerance percent defective, but the short term of that is reject quality level. So at the one end of the AQL curve, you've got the reject quality level, and at the other end of the curve, you've got the AQL. Now the AQL looks at, provides a percentage of what you're trying to achieve in terms of good product. So if you've got an AQL of 1%, it means that on average, in terms of your inspection, you'll provide a 95% confidence that the 1% of the products are likely to be defective or less.
Right.
Then RQL is on the other side, which very few people pay attention to, which is the bad end of the product. What is the worst case that you can send to the customer through inspection? Because, as I said, there are confidence levels in inspection because you're working on samples.
Yes. Yeah, so it's kind of like taking a representative sample size and saying like what the upper limits and lower limits are, and then saying, well, based on this small sample size I've checked, we assuming that the rest is going to be the same.
Correct.
Right.
Absolutely.
And John, why has AQL kind of persisted? I mean, everybody talks about AQL. What AQL level are you using? Is it the most effective way of inspecting goods at a factory these days? Are there alternative methodologies? I know we've spoken in depth about the 30-piece representative sample in a homogeneous batch. Can we talk around that a little bit? Because I tend to agree with you and your thoughts on that AQL shouldn't necessarily be applied anymore, and that the 30-piece homogeneous batch is more reliable and more effective. But, maybe you can break that down for us a little bit.
Okay, so inspection, you can't inspect quality into a product, so we have to build it. Okay.
Yes.
And so there are a lot of dimensions in terms of critical customer requirements.
Right.
So the approach should be to make the inspection as effective and as quick as possible. And
right.
The way to achieve that is to get close to the supplier. And ask him, you produce in batches. Keep the batches that are homogeneous together so that we can deal with a homogeneous batch and not a heterogeneous batch. Because if we deal with a homogeneous batch, we can reduce our sample size. But if you're dealing with a heterogeneous batch, then your sample size will be based on the AQL tables as provided.
John, just for the sake of everybody listening, what is a homogeneous batch and what exactly does that mean? I know what it means, but I'm not sure everybody else does.
Okay, sorry. Homogeneous means the product has been produced with the same material, the same people,
right,
same equipment, same production line, same management.
Right.
So homogeneous means, therefore, that the product in the batch is similar in those respects.
Right. So the whole, so John, can I just also? It means the whole batch that's made is made the same way, nothing has changed, right? Well, the minute you add any change, like maybe you produce it the next day, maybe you continue producing the next day, and you even change workers, or maybe get a new batch of material in, it's no longer a homogeneous batch. There's a space that something could change or deviate or be different from the first production, right?
That's absolutely correct. So to make the inspection effective, it is important to establish whether you're looking at a homogeneous batch to inspect, or is it a heterogeneous batch. If it's a heterogeneous batch, then you're tied down to the AQL sampling plans as provided. But if you can get it to a homogeneous batch, then there's opportunity to reduce the amount of inspection and achieve the same result as it was a heterogeneous batch.
Right. So you've always said to me that 30 pieces from a homogeneous batch is kind of the best result possible. Is that true? And why do you say that? And what is the science or statistics behind that?
Okay, so if you look at a population, a batch, a population, a homogeneous population, if you look at the statistics around that, they talk about the Z curve, okay? And if you take a representative sample from that, you can apply what they call the t-test, okay, which is a sample test. But statistically, it's been proven that if the sample batch is equal to or greater than 30, it's representative of the population, the Z population. And that
why
is why
30? Why 30, John? That's what I've always been curious about. Like, because I know with AQL, if you've produced 1,000 or 2,000 or 3,000, the table tells you pull 5 samples or 20 samples or 30 samples based on how many you've produced. But you're now saying as long as it's homogeneous, 30 is the number always. Is that true?
Yeah, so it's either 30 or more. The minimum is 30, and it's been statistically proven. It's been statistically proven that a sample of 30 or more represents the population confidently. Okay, so
Right.
without getting too statistical, that is the theory behind it.
Okay. As long as you can validate it's a homogeneous batch.
Correct. That's very important. Okay.
Yes.
So if you do that, then you can apply this thinking immediately to your inspection.
Right. So would it be safe to say, if you know your manufacturer is producing batches each day, that you could apply, say, inspect 30 per day from each production batch? Would that be reasonable? Or
that is absolutely correct. 100% correct. Your thinking is perfect.
Yeah. You know, I've long had this kind of thought process from just real life field experience over the last 20 years, where I look at the level of inspection that goes into product sometimes, and I go, like, I think you hit the nail on the head. You can't inspect quality into a product. It's got to be built with quality already. The inspections just to pick up, potential problems that might have gone wrong in manufacturing and making sure it's fit for market. And I find like the detail that goes into inspection sometimes is so overkill that sometimes obvious things are missed, and reducing that sample size, but really going deeper into the checking seems to make a lot of sense to me.
Yeah, there's a requirement, obviously, that the sampling must be random. It mustn't be biased. So it must be a random sample. So
Yes.
you don't just sample from a part of the batch. You treat the batch as one big batch, and you take from all aspects of the batch, so that there's no bias in the sampling. That's very important.
Yeah. And John, what are your thoughts or feelings in terms of, let's say you find defects or problems on a batch and it's already been produced, packaged, and ready for delivery? How do you weigh up or assess, will a rework, meaning an unpacking, rehandling, setting up production process to fix something, more things can go wrong? Whereas, what's your kind of decision-making factor to say, well, it's less risk to ship it as is based on the problems found, versus it's higher risk to rework it may cause a whole bunch of other defects or mishandling or even cosmetic defects potentially by reworking it. What are your kind of rules of thumb in gauging that? I mean, there's some obvious answers, but I just wonder if there's an approach in your language and world.
Okay, so the defect could be critical. If it's critical, then there's no discussion. If it refers to safety, then the whole batch must be reworked. No question.
Is safety the only benchmark for critical, or what are the top key marks?
No, there are others. They could potentially cause a very expensive repair. That could also be a critical requirement. So
right.
It depends if it's now a minor. If it's a minor, one could say to the customer, could you provide us a concession based on this minor finding? And we'll leave that to the customer to make a final decision. If the customer says no, then clearly you've got to rework it. And a major would also be a consideration similar to that. So the major is in between the critical and the minor. So I would suggest that if you have a critical, there's no discussion. You don't even go back to your customer. You institute a complete rework and address that problem without discussion. But if it's a major or minor, I would engage the customer to get his feeling on whether this should be reworked or not.
Yeah. Well, there's always two sides to that, right? Because everybody wants to deliver a perfect product. And it's I guess it comes down to, the way I look at it, is what would a consumer accept or not accept, and what is the cost of the consumer not accepting that? So I try to build down to common sense. What I find, John, and this is always an ongoing challenge, is very few people define upfront what they classify as major, minor, or critical in terms of what they're going to accept as a finished product. I mean, can you speak to that a little bit? I mean, how does a regular person who's purchasing products, for example, out of China, establish a list of majors, minors, and criticals to share with their factory up front.
So the inspection company should have qualified engineers that could interpret the impact of the defect finding and then assist the customer in making a decision. But what we must also be very careful of is that the manufacturer, the supplier, doesn't entrap the inspection company into doing their inspection for them. They must do their own inspection according to their quality management system, ISO 9000 preferably, and not entrap an inspection company to be their inspection. If you know what I mean.
Yeah, 100%. Yeah. They needed to inspect it and pass it. I always say we should check what their quality levels are internally first and how they pass their own goods. And if we're in agreement with that, we just like a second check kind of thing.
Correct. So what I would do, the inspection company, if they find a defect, I would say they should go to the supplier's quality inspections and ask if they had found such a defect. And if there's some correlation, then we know we've got a serious problem. But if there's no correlation, it could be just an outlier that occurred by chance. So these are the considerations that one should take into mind.
Yeah, yeah, that makes a lot of sense. I mean, you almost ideally want to be in a situation where the factory's got their own quality control systems and can do it without your need for an inspection in theory. And then your inspection is just kind of your third-party safety net.
Correct.
Yeah, no, I get that, and that's often misunderstood. And it comes back to that whole thing, which I live by. What you said that a long time ago to me. You can't inspect quality into a product. It's got to be inherent in the design and the way it's built and the way it's made, and so on and so on.
All right. So there's another consideration now. When you're doing an inspection, you're switching it on and you're looking and testing the product for maybe 5 or 10 minutes maximum. But what happens? What happens if the failure has a time dimension to it and it fails after a couple of weeks or months?
Yes.
Then you're not likely to pick that up in your inspection. So how do you address that? Well, it's very simple. If the supplier who is providing the product is not doing reliability tests, then that's a concern. So one should always study their reliability testing to make sure that there's no hidden defects that are time-based. And that an inspection company can do as part of their service to the customer is to say, well, we will study their reliability testing. Some of them do it in heat chambers, some do it in an ambient environment. It just depends on the way they've structured their reliability testing.
Yeah,
so
that makes
really important.
Yeah, that's critical. And sometimes also reliability tests are done coming back to the homogeneous concept on products that were produced at different times to your production. So it doesn't mean your production matches their original testing they did. You've got to keep on checking that, either by a lab or internally if they have the facilities.
Correct.
Yeah, it makes a lot of sense. John, I know this is a lot for people to digest, so I'm probably going to do some infographics and some nice help guides for them when we release this podcast. But what I wanted to close off on is just sharing. You just reminded me of a video that you once showed me, and I'm going to put that video in this podcast so people can watch it because it's so fascinating. When we were talking about improvement processes in a business or factory production line, you're talking about how improvements in a process speed things up. And I'll never forget the video you showed me. I've still got it. I'll add it to this podcast of the Formula One in, I don't know, it was 1950 or 60 or something, I forget. And they did when the car comes into the pit stop and they've got all the people doing the tire changes and cleaning the windscreen wiper. And it's like literally like I don't know, maybe a 2-minute process. And then, the car drives off. And then they fast forward to like 2016, the Formula One car comes in and then like under 2 seconds, they've changed every tire, the windscreen, the car's off. And like, it's the perfect way to understand how like processes change and can be super efficient and more effective. And like that blew my mind when you just saw how they were doing the work before and into how it became better. But like, it really puts into context the fact that you can't ever say anything's wrong. It's just, okay, how can I make it better, faster, quicker? I mean, and it's from 2 minutes to 1 second, just, it still blows my mind. But you would say it's impossible, yet it's not. It's happened.
You see, the application of that thinking is termed SMED, S-M-E-D, in Lean Six Sigma terminology, and it's very applicable to factories where they have to change over from one product to another, or one tool to another tool to produce
Yes.
product. And the idea is to do that as fast as possible so that you don't lose any time between producing one product and another. And,
yeah.
And that is...
That's a huge point, John. Yeah, you hit the nail on the head, because I know when I speak to a lot of factories, they want large quantities because they lose half a day of production changing from one order to another order, because they've got to change the materials, they've got to change the production line, do a few different things. So they've got this downtime. So that's why they want these huge quantities. And very few of them look at, well, part of my manufacturing process, not just the product, it's how do I run, like we come back to 5S, how do I run my factory so that I can do a tooling change, a production change in 10 minutes and not half a day, because you lose less productivity. And if they all thought like that, we just have this hyper-productive manufacturing environment. But it's not common in the middle of the range manufacturing in China, I would say.
Yeah, this concept was developed by, I think it was T.H.O. Ono from Toyota, who went to the States. And what he witnessed there was the 500 race. And he observed
Indy 500.
Indy 500, that's it. And he observed this changeover in the race. And he thought, well, why can't I apply that to my production? So the concept was born by the Americans, but they didn't apply it in their factories. But it took this gentleman from Japan to observe this and then apply it to his factories. And similarly, he went into supermarkets, and he saw how the Americans were allowing customers to pick their product from supermarket shelves and so forth, which led to the factories designing their warehouses in such a way that they can order in time and so forth, just in time and so forth. All of these concepts Americans developed, but the Japanese applied it and successfully beat them to the marketplace with quality and so forth.
Well, I'll close that off by saying, and then Steve Jobs came along and showed the Japanese how to do it, but with the voice of the customer being at the forefront, and took it all back.
Yes. But who produces the phones?
Well, the Chinese do at the moment, but the processes are all designed in-house by Apple with those Japanese philosophies, interestingly enough. So, yeah, I mean, these things are just spreading, right? It's once you see it, you can't unsee it, as they say.
Correct, 100%.
Well, John, thank you so much. I mean, I know you and I could talk for hours on this, but I want to try to keep it condensed so people understand it and get it. And, hopefully we'll be able to do a follow-up sometime soon. Great. John, thank you very much. Joyce, do you have any questions from your side? I know you've been listening there, probably a lot to digest, but any questions on your side?
No question, but that is quite a bit to digest and for everybody to actually think about along the lines of the inspections and everything, and how you can't put quality in a product, just inspect quality in a product.
Inspect.
So yeah, exactly.
Exactly.
So. There's also another aspect that we haven't discussed, but maybe we could do it at a later stage, is the statistical aspect of quality control, okay?
Right.
Which looks at the variables. We spoke initially about attributes and variables. where statistical control is very much focused on the variables, how to maintain that quality during production. So there are a number of techniques like process capability, control charts, and so forth that factories could employ into their processes to get better quality.
Yeah. In fact, you gave me a great idea, John. What we'll do is we'll do a follow-up podcast on in production process control and kind of the value of doing that and when we should do that. Because I think a lot of that comes to process control during production, which I think is a whole topic on its own we should dive into.
And if they do that properly, then you don't have to do any inspection at all.
Yeah. And if you monitor that properly, it gives you that peace of mind that the inspection's theoretically an unnecessary thing, but that's a very long discussion to have, yeah.
So if they are doing proper process control, then the inspection company could then go and audit the process in terms of statistics instead of having to inspect product, you see?
Yeah, absolutely. And if you can get those statistics in real time, it goes to a whole new level. And I mean, we've actually set up cases where we've actually put people on a production line writing down these statistics, and we tap them in real time. We get these deviation curves. So those are all things possible. I think when you're working long term with the supplier, with big production runs, makes a lot of sense.
Yeah, correct.
Great. Well, we're out of time, so I have to cut us here, guys. John, thank you so much. Joyce, thank you so much for your time. And guys, remember, if you need any help, go to globaltqm.com, schedule a free consultation call, and we always here to help you with any questions and just give you advice and support as your team on the ground in China. Goodbye, guys.
Thank you for listening to the GlobalTQM.com podcast. So you don't miss a single episode, remember to subscribe to our show on iTunes. We'd also be very grateful if you'd leave us an honest rating and review. And don't forget to download your free gift, our ebook on China sourcing for startups at GlobalTQM.com/gift.
How's it, John? How's it, John? You're on mute, John. You're on mute, and your camera's not on.
Good. Can you see me?
No.
Let me just see.
Maybe it doesn't think you're good looking enough. Can you see us?
I can see you.
You see, because we're good looking, John. That's you
Yeah,
see what happens
yeah.
when you're good looking. Your camera will show you.